Hello, welcome. Welcome to our live GCSE Maths session. I hope you are doing great this afternoon. Today we have got indices from GCSE Maths. We will be starting very shortly. I'm just setting up my screen, my my tablet to go on the screen. For those of you joining us for the first time, the way this works is we have I'll be giving an introduction to the topic of indices, and then we have got lots of examples that we'll solve together. I'll go through many examples. I will just put the um, the question file that I'm going to use in the chat in 1 minute. Let me set that up. There. Yeah, let's got my screen up. So the indices topic is for GCSE. We are going to look at both foundation and higher sections. So the first at the beginning, what we are going to do is going to be for everyone, for foundation as well as higher, and then in the second section we are going to look at higher content. Hi Mohammed, welcome. Good to see you join us. I'm having a little bit of an issue putting my screen on, so sorry about that. Thanks for your patience. I'm gonna just restart the program that I used to connect. So if you give me a few moments, it should be up there actually. Hi Kushal, good to see you. Let's see if we have. Right, so I can see it there. Okay, so my iPad is on there. Yep, I think it is working, so that's good. Let's get started. So, as I said, I have got many examples. We are gonna go through them. Let me put the link in the chats too. Right, so if you have a look at the chart, that's where the questions we are gonna go through are. So you can open them on your, you'll see it on my screen, but you can open it on your computers as well, so that you have a copy. It's gonna be easier for you to follow. Thank you, Ahmed. It's been a great day. It's been a bit busy, but it's quite good. I hope you're well as well. Which standard? Which standard? I think like we are starting with like everyone. This is foundation and higher GCSE. It's in all exam boards. Indices is a common topic, and then I'm gonna point out when it's gonna be higher tier. So I want to start with what we will use really. This is we are gonna see how these work with examples, but the idea here is, say you have got x to the a times x to the b, that's the same as x to the a plus b. So if you're multiplying indices, as long as the base is the same, you add the powers. So that's the first rule. And then in division, you subtract. Add the powers. Here we subtract the powers. And then if you have a power to another power, you multiply them together. So these are the three rules, and the other one I want you to remember is x to the 0 or anything to 0 is 1. So that's the other one. We'll see how these work. Let's put these together. I'm gonna go through these questions. Click the link in the chat to get to this file, and let me know if you have any questions. Please use the chat. Let me know in there, and I'm gonna ask you questions as well. So use the chat to reply. So here it says simplify. First thing you need to do always is make sure that the bases are the same. So these don't work. The rules that I showed at the beginning, they don't work unless the bases are the same. So you verify that the bases are the same. They're both m. We are multiplying them, which means we add the powers. So this is going to be m to 3 plus 6, so m to the power of 9. That was the multiplication. Here we are dividing them. The bases are the same. So what we need is p to the 8 minus 2. So that's going to be p to the 6. So this is just applying the rule. So we had the same base, we had to the power of 9, 2m. So that's a good question actually, or a good misconception, let's say. Let's clarify why this is not 2m. So here we are multiplying. If you want to write this out, let's write this out in say long. So I told you that if you have x to the a times x to the b, the rule is x to the a plus b. But why is that the case? Why is the rule just instead of 2x, I just said keep the x the same? So can someone tell me what, let's say in this case, let's use this example. What does m to the 3 mean actually? So if you want to write it out in the long way, what is m to the power of 3? M to the power of 3 is m times m times m. And then if you want to write this out, what's m to the power of 6? Well, it's gonna be m times m times m, and then this just goes on 6 times. So what this is telling you is to just multiply those two things together. So now you can see that you actually have 9 m's. Here there are 3 of them, and then these are 6 of them. So you can see how they're combined now. This is m to the 9. So this is why we have the rule, if you have the same base, m to the 3 times m to the 6, they become m to the 9. Right, that's why it works. And then the same thing applies with division. You can again write this p to the 8 as p times p times p. I'm just gonna quickly write that, p times p times p. Let's cheat a bit. So put that there. running out of battery. So that's 8 times p's, and then you divide them by p times p. So the two couple of them will, this p divided by that will be 1, that one will go away with that. That's how you end up with p to the 6. So that's how it works. And then let's apply the rule here. How does this work? Let me go back to my. So firstly, here it's not a simple case of I said x to the a to the b. We have got more stuff in the bracket. So how does this work? Can someone tell me? When you have two terms inside the bracket, what happens? So because this is 2 times n cubed time to the power of 4. So first thing to remember here is when you have expressions like this, the power belongs to both of the terms. So this is the same as 2 to the power of 4 times n cubed to the power of 4. Right, so that's another rule, and I'm gonna, as we see these rules, I want to add them to our list. So we have got, I'll just keep, because this is not a bit different, I'll keep that on the side. But we have got, say, xy to the a, that's the same as x to the a, y to the a. So if you have a bracket and just the power, but the bracket has two terms, you have got that power being applied to both of them. So in this example, we had 2 and then n cubed. They are two separate terms. They both are gonna have that power of 4. Rebecca, yes, 2 to the 4, and then the other bit, 3 times 2. Can I explain all the rules? So, well, as I had the list of the rules at the beginning there, and I'm adding the rules there. We're gonna have as we go along and as we see the rules, I'm going to add it to the list. So you will have a list at the end. I'm going to upload this, or at the end I can scroll back if you want to have a note as well. But the first two rules we explained with these, why you add and subtract. And here the rule we said is the power applies to both of them, both the terms, so both to the 2 and n cubed. And then you need to say, well, what is 2 to the 4? 2 to the 4 is 2 times 2 times 2 times 2. So that's 16. And then we times 16. We look at this bit. What's the rule there? N cubed to the 4. If you go back to the initial notes that we did, we are going to need to multiply them. So this is n to the 12. So we multiply the two powers. Okay, Ishal, why did the 2 went upwards? What do you mean upwards? So are you referring to this 2? So this 2 goes upwards because when there is a bracket with two terms and there's a 4 there, that 4 applies to both of them. You can think of it as, when you have brackets, instead of a power, say you have a bracket 4 times x plus y. You multiply x by 4 and then you multiply y by 4. So that's what brackets do. You can remember this as well. It's a good reminder that power of 4 belongs to, or it affects both of the terms. It's not just n to the 3. So that one is gonna be 16 times n to the 12, or you can write like 16 n to the 12. You can avoid the multiplication sign. Ishal, the P1. Okay, so you're referring to part A or B? Oh, let me see which part. I did the 2 went upwards. Not really. Okay, so with this one, we subtracted. It was 8 minus 2 because this is 8 of them, and then this is 2 of them, and then you. Right, let's continue with these. So let me know if there's anything that's not clear. If it makes sense, give me your answers to 2A and 2B. You're welcome, Ishal. And yes, it's basis of indices, so it does start easy, but we're gonna build up on with the other questions. How to attract? Yep. Right. Let's do these ones. This is the first rule. Same base. You need to add them. So 6 plus 7, m to the 13, and oops, x to the 0. This is, you just need to know, remember that anything to the 0 is 1. Right, moving on. Question 3. We have got m to the 5 divided by m to the 3. Remember, division is taking away the powers. So this is going to be 5 minus 3, so m squared. Let's look at this one. Tell me what you get to this. This looks a bit more complicated. 2a, we have got Rebecca. Do we agree with Rebecca? M13, yep. Thank you, Rebecca. And let me know what you get for this one. Because here we have got different terms multiplying each other. But you can, firstly, you need to remember that even when there are no multiplication signs, when you have 5 and then x to the 4, they're all multiplied together. So having the multiplication sign here doesn't really change much. So this is all, I'll just rewrite them as 5 times x to the 4 times y cubed x squared times y. So we are all multiplying these things together. That's what you need to really remember. It doesn't none of them are special. So if you're multiplying all of these together, what is the rule? What was the condition for when we can add the powers? So remember that the bases need to be the same. So you can't, if one is an x, one is a y, you can't really do anything with them. Thank you, Rebecca and Mohammed. Do you agree? Let's see. 5x squared y squared, 5x to the 6 y to the 4. Let's see who I will agree with. So what I'm saying is you can only combine or add or subtract, depending on if it's division or subtraction, these two together because they're both x's, and then y and y together. Right, if you've done that, move on to the next one. Let me know what you get as well from those. So they're multiplication, so you need to add the powers, but you can only do them with x and x together, y and y together. The 5 is just a number, you're not timesing it by another number. So 5 stays, then you have got x to the 4 plus 2 times y to the 3 plus 1. So 5x to the 6, y to the 4. Yep, that's thank you, Rebecca. That was correct. Well done. And yes, I think yeah, you did. If it was division, you would have been correct, Mohammed. Right, let's see what comes next. Let's do these. Let me know what if you have got an answer to this already. Let me know what you have. Let me see. Else is there. Right. Same basis. A to the 4 plus 5. A to the 9. And here we have got multiple terms. But remember, the rule is you can deal with the f's together. So we look at these together. We look at the e's together because those have the same base. And then you look at the numbers, the constants together. Right, we have a to the 9. We agree with that. That's great. And then tell me what's part B. Part B, I'm going to go 45 divided by 5. What's that going to be? So that will be a 9. And then e to the 5, f to the 6. So I got this because I did e to the 6 minus 1 and then f to the 8 minus 2. Let me know who agrees with 4. Then I will do 5 and then we're gonna move to a bit different ones. So 5, same base, m to the 2 plus 4 is m to the 6. We take away y squared. And then this is the third rule that we saw. This is m to the 3 times 5. So m to the 15. Okay. 9e to the 5. F to the 6. Yes, it looks like we agree. Yep. Let me know if you have any questions. I want to move on. Let's see which one that we haven't done yet. Right. So there are some more questions of the same type here. If you wanna try them, do them on your own time, or you can do them now. Let me know what answers you get. And I want to move to these now. So let's look at question 14. Here you are asked to write as a power of 7 these. So instead of x's and y's, we have got 7 base. But the idea is it doesn't matter. It will still be it still is the same base. So 7, it still works. So you need to apply the same rules. So this is gonna be 7 to the power of 8 minus 3. So 7 to the power of 5. Hi there. The session is it's about an hour, so we're gonna go until 6 o'clock. Right, that's 7 to the 5. Here we have got, remember, if you don't have a power, it's the same as having power of 1. Thank you. That's well done. That's the correct answer. And here we are going to have 7 to the power of 2 plus 3 divided by 7 to the 1. So this is 7 to the 5 divided by 7 to the 1. So the top one, the numerator is an addition, multiplication. So I added the powers. And then here I need 7 to the 5 minus 1. So 7 to the power of 4. And part B says write down the reciprocal of 2. Reciprocal, remember, it means you do this. Reciprocal of 2 is 1 over 2. Right. So that's the first section I wanted to do. Then we are going to move on to the next section, which is going to be, oops, let's see that. So in the next section, I'm going to look at fractional and negative indices. So this is the section where it's only for higher tier. Checking the chart half. So the until now it was foundation, the when you had integer powers and positive powers, but the fractional and negative indices are higher. So the questions. Oops, no, that's not the one. So we are gonna see how negative values, negative indices, and fractional indices work. So if you have done these, who can tell me how these work? So who can tell me what x to the minus 1 is? And then this is actually just relates to the previous question. We talked about the reciprocal there. So let me know what x to the minus 1 is. And let me know what x to the half is. So based on these two, we are gonna build up on more complicated ones as well. Because x to the minus 1 is the same as 1 over x to the 1, which is 1 over x. And this is what we called reciprocal in the previous question. And x to the power of a half is the same as root x. And yep, square root x is x to the minus of a half. What about x to the, say, a third? This is the third root or the cube root of x, and so on. You can extend this. You can go fourth. This is the fourth root of x, and so on. So from these, you can build up to more complicated expressions. Also remembering the rules that we had at the beginning. For example, you can have things like x to the minus 2. So what does x to the minus 2 mean? You need to think of x to the minus 2. You can think of it as x squared to the minus 1. So here comes where you should be really combining what you know from before, what we saw at the beginning, with the idea of the reciprocal. So the most important thing to remember is that x to the minus 1 is the reciprocal. So applying that idea here, you can, instead of just being 1 over x, here you're going to say, oh, this is x 1 over x squared. So this is how you should think about it. Remember that x squared to the minus 1 is the same as x to the minus 2 because of the first rules that we saw, which said if you have power to another power, you multiply the powers. Because when you multiply the powers, you get the same, you get minus 2. So these two things are the same. And considering these two things are the same, anything to a minus 1 is the reciprocal. So I'm applying two rules here. Going from here to there, I apply the rule that x to the a to the b is equal to x to the ab. So that's why they're the same. And then going from here to there, I apply the reciprocal rule. So that's how we can combine the two and see how see what x to the minus 2 is. And you can do other combinations as well. You will see that, say, x to the power of 3 over 2. You can think of this as x to the power of a half cubed, which is the square root of x cubed. So again, I'm going between these two, I'm using the rule that x to the a to the b is x to the ab. Right, let's apply this to some questions. It will make more sense as we see them applied. Right, 36 to the power of half. You need to remember this is the same as square root of 36, which should be just a 6. What about the next one? What's 3 to the minus 2? We said that this is 3 squared to the minus 1. So you flip 9. So it's 1 over 9. So you can, if you have a negative sign, negative power, it means the reciprocal of. You flip it and then you still do the same. This one we saw before, it always becomes 1, and then this is the reciprocal, you flip it, so it's 1 over 4. Question 3 and 4, let me know what you have in the for both of these questions. And then let me know if you get question number 5. 2 to the 0, anything to the 0 is 1. 5 to the minus 1 is flipping, it's the reciprocal 1 over 5. Then this one, it is 2 to the power of minus 1, 1 over 2. So every time there is minus 1, we are flipping, we are taking the reciprocal. This is the square root. 8 times 8 is 64. Thank you. Well done. Looks like we have the correct answers there. And what about 5? Have we got the answers to 5? We again have a to the power of 0. That's gonna be 1. This is gonna be flipping it, so that's 1 over 16. So you're squaring and flipping. Okay, that's 5i, and then we have got the square root of 100, which is 10. Okay, that's question 5. Let's see what we should do next. Let's look at question 6. I think that's a good one. The first two are similar to what we did before, but have a look at B, 6b and 7b. Let me know what you get for 6b and 7b. Let's see if we can find the answers. Probability, you want probability, that's Venn diagrams, probability. Yeah, that's something we can add on to the list if that's a topic that you're finding tricky. 9 to the 0, this is 1. So anything to the 0, it doesn't matter what the power, what the base is. It is going to be 1. Then we have got root 169. You can probably recognize this as 13. What is this? Part B. Does anyone have an answer for part B? 64 to the power of 2 over 3. So this is where you should remember the rule that says power to a power, you multiply it. Oh, I wrote 63. That's not really helpful, is it? This is 64. So I'm going to consider that 2 over 3 is the same as 2 times 1 over 3. So I can write this in two ways. I can write this as 64 squared to the power of a third, or 64 to the third squared. Which one would that? Which one would you use? Which one is better to use in this case? So some answers: 16, Rebecca. Think we have 16, but how did you get there? So I can see we have got cube root of 64 is 4. So I agree with that. The idea is I out of these two options, they're both correct. They're not, neither one is wrong, because 2 times a third is 2/3, a third times 2 is 2/3. They're both the same. However, to make this easier, it's better to first cube root and then take the square. Otherwise, you would need to find the square of 64 and then take the cube root, which is not going to be very easy to do without a calculator. So what is, let me rewrite this as the cube root of 64 all squared. And then you can recognize the cube root of 64 as the 4. You square it, so it becomes 16. So this is the really important with this type of indices, the fractional indices. You want to first take the power down. So you want to take the square root or the cube root and so on first, and then raise to the power. So 2 over 3 is better written as a third first, cube root first, and then take the square. Right, 7b. 7b is similar. Let me know what you get for 7b and how you do it. 7a is simpler. 36 to the half is the square root of 36. That's gonna be just a 6. But what about part B? So you should think, what's the best way of rewriting this? So this is gonna be 8 to the third, and then square it, because I want to always take the cube root or the square root first and then raise it to a power. What about the minus sign though? I just didn't do anything with it. Remember, minus sign makes you take the reciprocal or flip it. So instead of this, it's simply 1 over that. Yep, that's about, thank you. Cube root 8 power to 2, and then don't forget to flip it. That's why we can go 1 over 2 squared, 1 over 4. Right, let's see what comes next. Let me know if you agree, and try question 8. So the first bits should be the first one should be easy. Then we have a negative power and then a fraction. So we have got 4. We have got a fourth. Yeah, that's be careful. Don't forget the negative sign. So if you did get a 4 here, it just means you forgot the minus sign. So but taking the cube root first is the way to go. Right, let's look at question 8. This one is 1, as always. This one is 1 over, because we have the negative sign, 4 squared, so that's 1 over 16. Then we have got the We have got the next one, which requires you to split it into two steps. So you have got 16 to the half cubed. Always do the root first. So this time it's square root. So that's going to be 4 cubed, which is 64. Okay, that's question 8. Question, let's see what happens with question 9 and question 10. So if you have a look at these ones and let me know what you get for this one, question 10, 4. So let's hear your answers from them. I'll go through these. These are simpler. We have got a root of 25, which is just a 5. Then anything to the 0 is 1. Question 10. Question 10, first one has a negative sign. So we need 1 over 3 squared. The negative sign is just flipping it. And then we have got 1 over 9. This is going to be root 36, which will be 6. And here I am going to do it in two steps. This needs to be 27 to the 1/3. So I take the cube root first. Always take the root first and then raise to a power. So what's the cube root of 27? That should be 3. And then when you square it, you're going to get a 9. Right, so how do we do this one then? If you if you have an answer, let me know. Or we have done one with a negative fraction before, but this time there's a fraction inside the bracket as well. The idea is still the same. The negative sign will still make it reciprocal. But what is the reciprocal of a fraction? So if previously we had just constants, it was a 2, 2 became 1 over 2. You took the reciprocal, it was 1 over. But what is the reciprocal of 16 over 81? Reciprocal of 16 over 81 is 81 over 60. So you flip the fraction. With numbers, we don't have anything. It's like having a 1 in the denominator. That's why it becomes 1 over. But when you flip a fraction, 16 over 81, it becomes 81 over 16. Thank you. Well done. And that means you can write this as 81 over 16 to the power of 3 over 4. That's how we get rid of the negative signs. And that's the first thing you can do. Then remember, you want to take the root first. So 81 over 16, 1 over 4. And then you're going to take the third power out. Right, we have got a couple of different answers. Let's see which one we'll get. Let's see if you agree with 9 over 4 or the other one. I am gonna take the fourth root of this fraction. Okay, but how does that work? If I have a bracket, if it's a fraction, how do I take the root of a fraction? Mohammed, let me know where you're confused. Okay, let's go through this again. Go through every step. So, but if you let me know any particular bits that you were confused with, write it in the chat. But what I did was get rid of the negative sign by the reciprocal. I think that should be okay because we've done that before. You just flip the fraction and get rid of the negative sign. So that's where we are at now. And then what I'm saying is similar to, say, this question. You know, in this question, we said we had something to the power of 2 over 3. And what we did was that same thing inside that number, this was 27, take the third root and then square it. So I'm going to do the same thing here. Whatever number I have, I'm going to take the fourth root and then cube it. Instead of having a 27, I have a fraction, but it doesn't matter. It's still my number there. I'm going to take the fourth root and cube it. So this is where you need to remember how to take the fourth root or square root of a fraction. I'll make a note of that here. So this is our first note. The other one you need to remember is that if you have, let's say, let's make a simpler example, 9 over 4 to the half. What is the, I want to take the square root of the whole thing. What's the square root of 9 over 4? This is the same as the square root of 9 divided by square root of 4. So we saw this at the very beginning. If you had two terms in a bracket, you took a power, it applied to both. It's the same with fractions. You need to take the square root of both the numerator and the denominator individually. So this is going to be 3 over 2. So that's the rule. Take the square roots or the fourth root individually. Right, let's apply it here. What's the fourth root of 81? Okay, let's do this one. Fourth root of 81, it's gonna be 3. I think it's 3. And then we need the fourth root of 16, which is a 2. This needs to be cubed. And then same rule, you apply it individually. So 3 cubed is 27, 2 cubed is 8. Right. Reciprocal. Yes, Mohammed, you're right. We in previous examples we were using constants, just whole numbers, so it became 1 over. But the rule of the reciprocal is flipping it. If you have, which is actually the same thing, because if you have, let's say, reciprocal of 5, let's say. But you need to remember that 5 is the same as 5 over 1. So when you flip it, it becomes 1 over 5. That's why we said, okay, do 1 over. So it's still flipping. Yep, well done. You had 27 over 8. That was correct. That was correct. Rebecca, I think you got it as well. Lebatho, well done. So yeah, remember, if it's always flipping, and remember that a whole number such as 5 is the same as 5 over 1. That's why it becomes 1 over 5. Okay, that was nice question. Let's see what we have next. Let me choose some interesting ones. Okay, let's continue from question 13. Okay, let's skip these, and I'm gonna look at 13. And then go on to 14. Right, this is one where we have a power inside the bracket. You have got 3 different terms. So what's gonna be the rule here? How can we do this? Because we have, oops, I don't want that one. So we have a term, that's the 3. We have another one, x squared, and we have the y term. So each of them will need to be cubed separately. So that's how, this is 13, that's how I'm going to find the result. 3 cubed times x squared cubed times y cubed. Then I have got 27 x to the, remember it's a power to a power, so 6, I'm multiplying 2 and 3, and then y cubed. Yep, Mohammed, what have you got? X to the 6, y to the 3. So you have the x and y powers, correct, well done, but don't forget the numbers also need the powers. It doesn't matter that it's a number, it's a constant, just like the others. You will need to raise it to the power of 3. So that's why I do it to 3 cubed, this cubed, that cubed. Okay, let's do it here as well. Let me know what you get. I am going to approach it in the same way. Remember, you have got 2 there. There's a 2. There is a t to the minus 3. So those are my 2 terms. And they each need to be raised to minus 2. Okay. 2 to the minus 2 times t to the minus 3 to the minus 2. What can I write about this? What's 2 to the minus 2? The minus rules are still the same. So it's going to be, to get rid of the minus, we flip it, or we do 1 over in this case. Because in the denominator, this is the same as having a 1. So this is 1 over 2 squared times t to the minus 6. Is this t to the minus 6? What is minus 3 times minus 2? When you multiply them together, you will get just a 6. Let me write that down explicitly. Minus 3 times minus 2. So 1 over 4 t to the 6. Yep, 1 over 4 t to 6. We agree with that. Well done. So let's move on to question 14. Let's see what we'll get there. So this is a bit different from the previous ones. We are given x is 2 to the p and y is 2 to the q. Expressed in terms of x and or y. So this term, or anything given in our question, we need to make sure we separate into 2 to the power of p and 2 to the power of q, which means we can do x and y, because otherwise we are not finding x or y. Rebecca, and it's 6. Yep. Okay, previous question, let's check that. 1 over 4 to the minus 4t to the, okay, that's an interesting one, that's a nice one. So you are saying in the previous question, you said 1 over 4t to the minus 6. Is that what you wrote? I think that's what you wrote. Is that the same thing? That is the same as 1 over 4 times 1 over t to the minus 6, which is the same as 1 over 4 times t to the 6. That is, yeah, that is correct. And I understand. You could have flipped it first. So you can see that once you get to some more complicated expressions, there are more than one order you can do things in. So you can first flip. Instead of what I did, you can first flip. You can just first say this is, so the alternative route would have been saying this is 1 over 2t to the minus 3 squared, and then 1 over 4t to the minus 6. So these are both acceptable. They're the same things. Okay, let's answer this one. Let's see what you had. There is x plus square root of y. Let's see if we agree with you. Um, um, so we have got 2 to the p plus q, and this is, I mean, there should be clear, but let's put brackets there. This is going backwards. If you think about the rule 2 to the p times 2 to the q, and then we said that if the bases are the same, you add the powers. It's going backwards. So once you have it that way, you can see that this is x times y. The second part, we have got 2 to the power of 2q. Well, remember, we want to have 2 to the power of q on its own. And I can write it like this, because remember, the power to a power rule says you multiply the powers together. If you multiply the powers together, you realize it's going to be 2 to the 2q, so this is going to be y squared. And what about part 3? Let's see what we can do here. We have got 2 to the p minus 1. So think about what needs to be done to subtract, to take away some power from them. The power is subtracted if you have a division. So if you start with 2 to the q and divide it by 2 to the 1, think backwards. Going backwards from this, you will need q minus 1. Then this is going to be 2 to the q, which is y over 2. Is it y? No, sorry, this is p. I'm not, it's this is not 2 to the q. This is 2 to the p, which means this should be an x. Right. That's part A. Let's look at part B. Part B gives you two of these. Xy is 32, 2xy squared is 32. You want to find P and Q. Right, let me know if you're happy with A or if you have any questions with A. Let me check the answers that you have. So there's 1 over x, 1 over x. Which one do you guys think 1 over x was? I don't think we had a 1 over x there. Let me, okay, if you have done part A, start part B, try part B, let me know what you get if you get the answer. But I'll just quickly recap this one. So what we were trying to do is always get a 2 to the q or 2 to the p in these expressions, so that if you have a 2 to the p somewhere, that's an x. And if you have a 2 to the q, that's a y. And to be able to get those, you think of your rules. But instead of starting with multiplication or division, and then we add the powers, these questions do it in the opposite way. We are going backwards. So you say, okay, if I had 2 to the p times 2 to the q, I would have added the powers. And because of that, you can write 2 to the p plus q as 2 to the p times 2 to the q. Think of you should be able to recognize that if the powers are added, it's a multiplication with the same base. And here the powers are subtracted, so it's a division with the same base. And then you look at what's being subtracted is p minus 1. That's why it's 2 to the p, 2 to the 1. So this is the idea going from stage the first expression to the next one. And once you have them, you say, okay, this is a 2 to the p, which is 2 to the p. This is a 2 to the p. And then wherever you see that, it's an x. This is an x. And then you have a 2 to the q here. That's your y. This is a 2 to the q. That's your y. That's the idea with in part A. Right. Let's look at part B. We are given two equations, and you want to find P and Q. They're simultaneous equations, and you want to solve them together. So since you are after P and Q, what would be your first step? You're given some information in X and Y. What would you do then? Like you can't really keep them in X and Y. It would be easier to change them into P and Q so that you can get to them. You can solve them simultaneously. I'll assume you're familiar with simultaneous equations. You might have done simultaneous equations. I'll explain that quickly. But firstly, let's get rid of X and Y. We don't want X and Y. You're after P and Q. So X and Y is not really gonna help you. Can we remind ourselves what they are? X is 2 to the p. Let me write them down. 2 to the p. And y is 2 to the q. So what I will do is just replace x and y with these things. So that may help us. We'll see. So instead of xy equals 32, I'm going to write 2 to the p times 2 to the q is equal to 32. Let me number these. So this is equation number 1. That's equation number 1. That's equation number 2. I'm going to write that one here. 2xy squared. So 2 times x. What's x? It's 2 to the p. And then what's y? 2 to the q. That's not a q. Squared is 32. Okay, I have these two equations. Can I get any suggestions how this is helpful, whether this is helpful at all? Because what I was saying that I need any equations in P and Q, such as P plus Q is 10, to be able to solve them. But I haven't really got there. I got rid of X and Y, but I haven't got anywhere with only P and Q. I still have these twos. So can anyone give me a suggestion? How can I get rid of these bases and make an equation in terms of P and Q? And does maybe what I did in part A help me? Can you see any similarities? Because if you look at part A, you will see that xy, which as I wrote here, let's make it like that. So xy is equal to 32, but from the first part of A, you can see that xy is 2 to the power of p times 2 to the q, which is what I wrote here. But if you go back at that stage, you'll realize that we can also write that as 2 to the p plus q as 32. Yep, 2 to the p plus q. Thank you, Sarah. And the other suggestion, thank you, Lethabo, make 32 an indices into an index. Because the idea is, I'll write this bit as well. That's 2xy squared. I have a 2 to the p. So 2 times 2 to the p times 2 to the 2q. So that's this one is equal to 32. But 32 isn't really helping us. We can write 32 as 2 to the power of something. So 2 to the p plus q, instead of, let me not write that, instead of 32, I can write it as 2 to the power of 5. And I'm going to do the same thing here, 2 to the power of 5. And how can I combine this side into just one? Let me know, because what's the rule? We are adding, we have the same base, we are adding them. I use the power to the power rule here, it's 2q. But if I'm adding them, what am I gonna get as a single base? So looking at, let me know what you get from here. I'm gonna look at this bit now. We are saying that 2 to the p plus q is 2 to the 5. So what can you make, what can you deduce about p and q? P plus q is equal to 5. That's what comes out of that one, because you have got the same bases on the two sides. So p plus q must be 5. And then, thank you, Sarah, 4 to the p plus 2q. So we have got, remember, we have got the 2 to the 1 there. And why am I? Okay. We want to keep the base of 2. So adding the powers, we have got 1 plus p plus 2q equal to 2 to the 5. So 1 plus p plus 2q must be 5. So now I have two equations. It's good to simplify this. Right, p plus 2q is equal to 4. And this is where simultaneous, they become just two simultaneous equations. So thank you, Rebecca. That's the simultaneous idea coming here. How do we solve these though? How can we solve simultaneous equations? So if I number this 3, and then if I call this one 4, so with simultaneous equations, you have normally two ways, two methods. You can either make one of the unknowns the subject and substitute, that's substitution, or you can eliminate by adding or subtracting the equations from each other. Since we have got a p and a p there, it's easy to take one away from the other, so that the p is eliminated. So if you go 3 minus 4, I'm going to take away the p from p. That's going to eliminate them. And then you get q minus 2q is equal to 5 minus 4. That is going to give you minus q is 1. If minus q is 1, q is going to be minus 1. And finally, you need to put it back into one of the others. So you want to find p. So you say, let's say in, do I have space there? Yeah. In 3, you go p plus q, which we just found is minus 1, is equal to 5. So p is equal to 6. Right, that's the end of this question. Let me see how we're doing with time. Yep, this is where I want to stop. Thank you very much for joining today. I hope this has been a helpful session for you. If you found it useful, please hit the like button and subscribe to the channel, and let your friends know these are weekly sessions I'm holding for GCSE Maths. And thanks for joining. I hope to see you next week.